In this video, I would like to look at one final set of transformations, compressions and stretches that occur when we take a function and multiply either the input or output values by a constant. If we multiply a function by a constant on the outside of the function, we are affecting the output values or the y values. So this will result in a vertical stretch or compression depending on what constant we multiply by. The y values are affected here. If we take a function and multiply the input values by a constant, we are multiplying the x values by some constant before we perform the operation of the function. Then we are compressing or stretching the graph horizontally. The x values are affected. And this works in the opposite way as it does for the y values, just like we saw with adding or subtracting something to x values. So if we multiply by a constant greater than 1 on the inside of the function, that actually results in the graph being compressed or pushed together horizontally. If we multiply on the inside by a function that is between 0 and 1, that actually results in a horizontal stretch. So that's the reverse of what happens with output values or y values. Let's see this illustrated with a couple of examples. Let's say I want to sketch the graph of 2x squared and the graph of 1/2 x squared. So those are both based on the toolkit function y equals x squared, which I've shown here in its general shape, and I've also shown some particular x and y values that belong on the graph of y equals x squared. Let's see how those would change for the functions f of x and the function g of x. For each of these, I might make a table of values as well. So we have f of x equals 2x squared. That means every output value, every y value, is being multiplied by 2. So instead of 0, 0, well, I still have the point 0, 0, because 0 multiplied by 2 is still 0. Instead of negative 1, 1, I have the point negative 1, 2. Instead of negative 2, 4, I have negative 2, 8, and so on. We are taking every output value and we're multiplying it by 2. When I sketch this graph, it will be a much steeper function than the toolkit function y equals x squared. So it passes through negative 1, 2, and 2, positive 8. That's way up here on the graph of the function. We end up with a function that looks something like this. So that parabola was taken and it was stretched vertically by a factor of 2. In contrast, if I'm sketching the graph of 1/2 x squared, we take every y value and we multiply it by 1/2, which is the same as dividing it by 2. So I would have 0, 0, I would have negative 1, 1/2, I would have negative 2, 2, and so on. This will result in a vertical compression. And let's see what this picture looks like. So if I sketch the graph of 1/2 x squared, passes through 0, 0, passes through negative 1, 1/2, and positive 1, 1/2, and then it passes through 2, 2, and negative 2, 2. So our vertical compression ends up looking like this. It's a much wider function than the one before. Now let's look at an example involving horizontal compressions or stretches. Remember that this works the opposite way as with the y values or the output values. So if I need to sketch the graph of y equals the absolute value of 3x, and I have some points on the toolkit function as shown here, for this graph, I'm going to take every x value, and I'm not going to multiply by 3, I'm going to divide by 3. So I would still have the point 0, 0, but then I would have the point negative 1/3, 1, negative 2/3, 2, and so on. And if we sketch this graph and the points that we've shown, this is considered a horizontal compression. The effect is similar to a vertical stretch. We'll see a much steeper function here. Every x value was taken and it was divided by 3. In contrast, if I sketch the graph of y equals the absolute value of 1/3 x, I would take every x value in the toolkit function and I would multiply it by 3. So here I have 0, 0, I have -3, 1, I have -6, 2, and so on. What we will see here is a much wider function. It is stretched horizontally by a factor of 3. So we'll pass through 3, 1, and -3, 1, and I'll run out of space to show these other points, but we'll see a very wide, shallow function. So these examples give some illustrations of vertical and horizontal stretches and compressions and some of the difference between the two.